deep in the Allegheny Mountains of West Virginia, in the middle of a rugged 13,000 square mile expanse known as the National Radio Quiet Zone, where the tools of our wireless age, like cell phones and Wi-Fi, are forbidden. A team of astronomers has detected a series of devastating high-energy bursts erupting from an unknown source far off in space.
We've been absolutely confident that these are extragalactic sources.
The signals keep coming.
So we've now detected hundreds of bursts.
And no one has a clear answer why.
What is actually giving rise to these very powerful flashes?
There's always a danger, like, well, maybe this is actually ET. We gotta make sure we're doing the right thing here.
To solve this mystery, scientists will search for clues billions of light years from home. Then come face to face with one of the strangest, most violent phenomena in the known universe.
If you get close enough, it will actually start to elongate the molecules, and it would rip the water out of your body.
The small towns of West Virginia's highlands are some of the most isolated in America. But today, one of them finds itself in the center of a cosmic mystery. All because of this, the Green Bank Telescope, one of the largest movable objects on dry Earth.
The structure here stands almost 485 feet above ground level. It's actually taller than the Great Pyramid of Giza. These huge wheels, 5-foot diameter steel wheels, are the support structure and actually roll on this track system. This structure weighs almost 17 million pounds. So each one of these 16 wheels carries more than 1 million pounds.
And the GBT is more than just strong, it's agile.
We can see more of the celestial sphere here in Green Bank than can be seen from any single telescope anywhere else in the world. We can see 85% of the celestial sphere from this point right here.
And the view from Green Bank has changed our understanding of the planets, the stars, and other cosmic phenomena. And from this remote place, Dr. Frank Drake pioneered the field known as SETI, the search for extraterrestrial intelligence, using the first telescope built at this observatory. He developed a formula known as the Drake equation to estimate the number of intelligent civilizations occupying our known universe today. Some have calculated that number to be well into the millions. Astronomers are now searching these same skies for clues to help solve a new mystery, the source of a string of unidentified signals they call fast radio bursts. They will do so by scanning the cosmos for radio waves.
A radio telescope is like any other telescope. It collects radiation from the sky. You're more familiar probably with an optical telescope, which collects light waves at visible wavelengths. Well, radio waves are the same kind of thing. They're just longer, bigger. Sometimes I call it tired light.
And the radio waves being detected by the GBT are so faint that even the slightest electronic interference would drown out the signals collected by its 100-meter dish.
A single cell phone on standby, not even talking on it, but just on standby waiting on a signal, placed on Mars, would completely overwhelm anything the astronomer is looking for.
Engineers have the daily challenge of shielding the telescope from the electronic noise bombarding it from space and closer to home. The instruments in the telescope's receiver are kept below -300 degrees Fahrenheit, bringing molecular motion to a near halt. The GBT's control room is sealed in copper, preventing any man-made signals from leaking out. Even life in and around Green Bank is dictated by the needs of the telescope.
We don't have cell service here. There is no Wi-Fi. It's prohibited completely. Television is a little tricky.
And the few microwave ovens permitted on campus have been encased in metal shielding.
You sort of live like people lived in the 50s.
The enforced silence around the telescope allows it to detect signals that few others can. "45 years into its journey, the Voyager spacecraft has left the solar system. It's more than 11 billion miles from Earth, beyond the reach of our sun. A faint beacon is its only connection to its home planet.
And it's emitting a radio signal which has the equivalent energy of about a 20 or 25 watt light bulb.
Astronomers at the Green Bank Telescope make an attempt to track Voyager down. They find it in a matter of seconds.
But we can pick that signal up with the GBT. It's actually a really bright signal, no problem at all. The signals that we're detecting from fast radio bursts are even weaker than that.
When fast radio bursts erupt, they can unleash as much energy as our sun does in an entire year, in a fraction of a second. But by the time that energy reaches Earth, it's a mere whisper. And while astronomers have now detected dozens of different fast radio bursts, one of them is different from the rest, and they're determined to find out why. They call it FRB 121102. The source of that signal now enters the GBT's field of view. From the telescope's control room, 1 mile away, Dr. Ryan Lynch directs the telescope to lock in on the target.
So the GBT sees a very small portion of the sky at any given time, so we have to be able to control where it's pointing very, very precisely. So if you think about a really little tiny crater or mark on the moon that you might be able to see with your naked eye, that's basically the amount of sky that we're seeing right now.
And there's an even greater challenge to observing 121102.
We don't know when it's going to actually emit a burst, and the bursts only last for a fraction of a second, only a few milliseconds. So we have spent many tens, probably hundreds of hours on the GBT over the course of the last few years observing this object, and hundreds of hours on other telescopes. And we've only detected a few hundred bursts. And if you were to add all of those bursts up, they would only add up to a few seconds worth of time when the source is actually active.
Like most observations, this one comes up empty.
This is such an interesting object, and it's such a big mystery in radio astronomy right now, that it's worth spending all of that time.
The Green Bank team's search for answers is about to get a major boost. Their partners with Breakthrough Listen, the world's largest SETI project, have made a major investment in the telescope's computing system.
If you have a laptop with a 1 terabyte hard drive, this represents about 4,000 of those.
Dave McMahon has installed enough new hardware to effectively double the observing power of the GBT.
So it's kind of like we got a big upgrade to our cable box. We went from standard to deluxe package. We're open for business.
The team hopes this upgrade will help them build on the few seconds worth of data captured on FRB 121102 so far. A few seconds that have set off a series of discoveries and made this one of the hottest topics in astronomy today.
When FRB 121102 was first discovered, everything got thrown into overdrive. We knew it was special almost right away because no other FRB event has been seen to repeat.
They realized they're dealing with a one-of-a-kind phenomenon, and because this one signal repeats, they knew they could tease more information out of it.
It's kind of like if you're in the woods and a bird chirps and you hear it one time, you're like, wait, what was that bird? I heard it, but I couldn't quite figure out what it was. And if you hear a few more chirps of the bird, then you might be, okay, now I know what this is. It's a robin.
They could now track the location of the signal to the constellation of Auriga.
Once we were able to localize 121102, we realized that this galaxy has never been seen before.
You know, sometimes I try to think about the incredible scale of all the distant objects that we're listening to, and it boggles the mind.
They now knew where FRB 121102 was coming from, but they still didn't know what was generating the signal. But each subsequent flash of energy helped them narrow down their list of suspects.
When fast radio bursts were first discovered, they were all one-off events. And so a lot of the early theories focused on catastrophic events that would destroy whatever was actually causing the fast radio bursts. That could be things like an exploding star, a supernova.
It was a huge explosion, maybe 2 neutron stars colliding. So when we start to see it repeat, that changes our whole paradigm of what it could be.
And it is still the only known fast radio burst that repeats. And that makes it an especially big mystery.
Once astronomers discovered that this wasn't a one-and-done phenomenon, they had to find a celestial body that could expel bursts of radio waves without destroying itself. They began to suspect that the signal could be coming from a pulsar. Pulsars are dead stars that emit radio waves so predictably that NASA has discussed using them as cosmic beacons, guiding future space missions. But the strength of 121102's signal is far beyond a typical pulsar's. And there's something else about these bursts that puzzles astronomers.
And you might think to yourself that with all of those bursts, we would be able to find some sort of a pattern or a regularity in when they're going off. But we've looked really hard and we haven't been able to find anything like that yet.
Because astronomers haven't been able to uncover a pattern to 121102's seemingly random burst cycle, they've had to search beyond pulsars for an explanation. Continuing the work begun here by Frank Drake more than 50 years ago, the astronomers from Breakthrough Listen wonder if signals like these could conceal a message from a distant civilization.
Anytime there's a new astrophysical phenomenon discovered, I think, aliens are one of the explanations for it that people put on the list.
In space, radio waves can be created by natural cosmic events, but they're rare. On Earth, we've learned that they can be created artificially by intelligent species like us. The energy emitted by 121102 is staggering, equivalent to 500 million suns, far beyond human capacity. But the scale of that explosive power does not concern SETI's astronomers.
Part of our assumptions in the SETI field is that we are just getting into radio technology. We've only had it for 100 years. And other civilizations could be far more developed than we are. I don't think that there's some fundamental limit to how strong a signal some intelligence could create if they wanted to.
The question for astronomers, then, is not just why this signal is so strong, but whether it carries any information.
When one gets a radio signal from outer space, you automatically start to think about extraterrestrials. While we can't rule out all FRB sources, we're pretty confident that FRB 121102 is not an ET source. With ET signals, one would expect a lot of information to be encoded into that signal, and all the information that we're getting from this burst has a natural explanation.
To demonstrate what an encoded message could look and sound like, Andrew Seymour has created one from scratch. Each pixel in this image of the Green Bank Observatory's logo corresponds to a different frequency and time. Think about them like a series of notes on a sheet of music.
Here, instead of having 7 or 12 notes that we may have on other instruments, we have over 1,000 notes being played here.
When all of those notes are played together, we see and hear this. And if we were to broadcast those frequencies into space,
If another civilization was recording with computers the same way we are, they would see this image come across their computer screens.
But when Andrew analyzed the signal from one of FRB 121102's bursts, he discovered something very different.
And one may think that there's information coded in that, but it has a natural explanation.
As strange as the sound and image may appear, Andrew finds nothing unusual or alien about them. Instead of a message, he sees a snapshot of an explosive moment from a distant galaxy. Many still believe that if we were to receive a message from a distant civilization, it would come to us cloaked in a radio signal like this. And that is one more reason why every new radio burst is met with such anticipation. Now that scientists have determined that the source of the unidentified repeating signal is unlikely to be a supernova, or a pulsar, or even a message from beyond our galaxy, they've turned their attention to one of the most exotic and violent phenomena in the universe: magnetars.
It's something that we love to study from afar. Don't want to get too close.
Like pulsars, magnetars are super dense remnants of stars that have gone supernova.
Imagine an object with the same mass as 500,000 Earths, but squeezed into about the size of a city. That's the equivalent density of taking every person on the planet and squeezing them into a sugar cube.
What sets them apart is their magnetic force.
Magnetars have the strongest magnetic fields in the universe. If you were to take a magnetar and place it at the distance of the moon, which would not be a good idea because it would destroy the Earth, but in the process, it would also erase all of the computer hard drives and credit cards on the Earth because of the strength of the magnetic field.
What a magnetar would do to a human body is even more alarming.
It will actually start to elongate the molecules in your body, and it would rip the water out of your body because those molecules themselves are slightly magnetic. It's not going to end well for you.
When a crack forms on a magnetar's rigid surface, it can set off a starquake, ejecting so much energy that it can be felt billions of light years across the universe. Magnetars are extremely rare on their own, and when scientists observed the radio waves from FRB 121102, they discovered something rarer still.
We saw that they were really twisted up, kind of like a corkscrew. And the degree of twist is higher than in any other source of radio waves that we've ever detected. So we think that this could be a sign that FRB 121102 is itself living somewhere near a black hole.
With radio telescopes like the GBT, astronomers are peering into deep space, tracing a series of cataclysmic events from deep time. A white-hot magnetar nestled in the orbit of a black hole, firing off instantaneous bursts of energy that billions of years later can be observed from Earth. But with every new discovery comes a new set of questions.
Within our own galaxy, we have something that's very similar. So why are these energetic events happening in other galaxies, but yet not our own?
I think all scientists are just naturally drawn to something that they can't explain.
Decoding FRB 121102 has revealed a part of the universe we never knew before. And it could also help us better understand the explosive magnetars discovered in our own galaxy as well. But in this quest, astronomers understand that timing is everything.
Even though we're only detecting the bursts now, they were actually emitted hundreds of millions to billions of years ago. So it seems like we're watching this drama unfold in real time, but in fact, the objects that have created these bursts may very well be long gone.
But even a signal from the distant past can be meaningful.
I don't know, I almost feel like a moral compunction to listen if we can, because it would be a shame to have these signals coming from somewhere else and we just sort of missed out because we didn't want to listen for them.
Our radio programs have looked at a few thousand stars. The optical people have maybe looked at 10,000 stars. So that's 10,000 stars out of a few 100 billion. So not a lot. And then I say, okay, let's set the volume of that space equal to the volume of the Earth's oceans. Then you come up with a very sobering analogy that so far we've searched about 1 8-ounce glass out of the ocean. So not a lot, but we're on an exponential curve. Our tools are getting better and faster.
The growing number of signals picked up by the world's radio telescopes are generating an ever-increasing flow of information from across time and space. There is no limit to what they might tell us about our universe, so long as we remain curious and continue to look and listen to the stars.